The planet you are standing on right now has tried to kill everything on it, more than once. Earth is 4.6 billion years old. Humans have existed for roughly 300,000 years. That means for 99.99% of this planet's history, we were not here. And what was here, what actually occupied this world before us, was so strange, so violent, so utterly unlike anything you've ever seen, that if you could step back in time and look at it with your own eyes, you would not recognize it as Earth at all. The sky was the wrong color. The oceans were the wrong color. The air was poison. Giant dragonflies with 2-foot wingspans ruled the skies. Creatures that looked like living carpets crawled across the seafloor with no eyes, no mouths, no bones. And before any of that, before life, before land, before anything, this planet was a spinning ball of liquid fire, bombarded by asteroids, wreathed in volcanoes, its surface a churning sea of molten rock, stretching from pole to pole. This is Earth before us, and it is one of the most extraordinary stories ever told. We start at the very beginning. 4.6 billion years ago, the solar system was still forming, a vast, rotating disk of gas, dust, and debris spinning around a newly born star. Gravity was pulling everything together. Chunks of rock and metal were slamming into each other at tens of thousands of miles per hour, merging, growing. Within a few tens of millions of years, a body roughly the size of today's Earth had accumulated at just the right distance from the Sun. But what happened next would define this planet forever. A Mars-sized world, scientists call it Theia, came screaming in from the outer solar system and struck the proto-Earth in a collision so catastrophic, so complete, that both bodies were essentially vaporized. The energy released was incomprehensible. Billions of nuclear bombs all at once. The entire planet melted. The debris that was blasted into orbit, a ring of molten rock and vapor, eventually coalesced into the moon. The moon we look up at every night is the scar of the most violent event in Earth's history. And in the aftermath of that collision, our planet entered its first named era, the Hadean. Named after Hades, the ancient Greek word for hell. The name is not an exaggeration. The surface of Hadean Earth was a global magma ocean, liquid rock, hundreds of miles deep, glowing red and orange under a sky choked with volcanic gas. There was no crust, no land, no water in any liquid form. The atmosphere, if you can call it that, was a thick, crushing blanket of carbon dioxide, hydrogen sulfide, water vapor, and sulfur dioxide. Asteroids rained down constantly in what geologists call the Late Heavy Bombardment, a period around 4.1 to 3.8 billion years ago when the inner solar system was pummeled by a cascade of impactors large enough to remelt the surface every time a thin crust tried to form. And yet, somehow, something miraculous was already beginning. Tiny grains of a mineral called zircon found in ancient rock formations in Western Australia have been dated to 4.4 billion years ago. These zircons show chemical signatures that suggest liquid water existed on Earth's surface even during the Hadean. How is that possible on a world covered in magma? Scientists believe that during brief cooling periods between asteroid impacts, enough of the crust solidified to allow water, delivered partly by comets and icy asteroids, to pool in shallow depressions. The planet was already reaching for something, already building the stage for what was to come. By around 4 billion years ago, Earth had cooled enough that a permanent crust had formed. The Hadean was over. The Archean had begun, and this is where it gets deeply strange. The Archean Earth, from 4 billion to 2.5 billion years ago, would be unrecognizable to any modern eye. The sky above you was not blue, it was orange. A thick, hazy amber orange, exactly like the sky of Saturn's moon Titan today. The reason? The atmosphere was loaded with methane, produced in enormous quantities by the only life on the planet at the time, microscopic bacteria. These bacteria blanketed the shallow oceans. They carpeted the rocks. They breathed carbon dioxide and exhaled methane. And that methane reacted with ultraviolet radiation in the upper atmosphere to form a dense photochemical haze, an organic smog that blocked sunlight and turned the sky the color of rust. The oceans were not blue either, they were green, or in some areas, depending on the concentration of dissolved iron and the density of microbial life, a reddish rust color. Iron was abundant in the ancient seas, and with no oxygen present to oxidize it, it stayed dissolved in the water, turning entire stretches of ocean into something resembling a vast, murky, iron-rich broth. The moon was dramatically closer to Earth. Back in the Archean, it sat roughly 150,000 miles away, compared to the 239,000 miles of distance it keeps today. It loomed in the sky, enormous, dominating the horizon. The gravitational pull of this closer moon drove tides of staggering height. Some models suggest ancient tides reached hundreds of feet in coastal areas. The entire ocean heaved and crashed in daily cycles of violence that are almost impossible to picture. And yet, life was there. They were the dominant life form on Earth for over 2 billion years. 2 billion years. That is longer than the gap between the Cambrian explosion and today. For most of Earth's history, this planet's most complex organism was essentially a microbial carpet. But inside those quiet, unremarkable mats, a revolution was building. Cyanobacteria had evolved something new, something catastrophic, something that would change everything about this world and ultimately make animals and us possible. They had evolved oxygenic photosynthesis, the ability to split water molecules using sunlight, absorbing carbon dioxide and releasing oxygen as a waste product. And for hundreds of millions of years, the oxygen they produced was immediately absorbed by dissolved iron in the ocean, by volcanic gases in the atmosphere. The planet had a massive chemical buffer that kept absorbing every molecule of free oxygen. But around 2.4 billion years ago, that buffer ran out. The iron in the oceans had fully oxidized. The volcanic sinks were overwhelmed. And suddenly, oxygen, toxic to most life on Earth at the time, began accumulating in the atmosphere. Scientists call it the Great Oxidation Event. Others call it the oxygen catastrophe. Because for the organisms that had ruled this planet for over 1 billion years, it was exactly that, a catastrophe. The sudden spike in atmospheric oxygen was like a planet-wide poison gas attack. The vast majority of Earth's existing microbial life was wiped out. The Great Oxidation Event may be the single largest mass extinction in the history of life on this planet, and almost no one has heard of it. But the story doesn't stop there. As oxygen destroyed the methane in the atmosphere, the orange haze cleared. Sunlight reached the surface more directly. And here is the cruel twist. Methane is a powerful greenhouse gas. Once it was gone, Earth lost its primary heat blanket. Temperatures plummeted. The planet froze. Not partially, completely. This is what scientists call snowball Earth, and it happened at least twice, possibly more often, in Earth's deep past. The first major event, the Huronian glaciation, occurred roughly 2.4 to 2.1 billion years ago, triggered directly by the oxygen rise. The second cluster of events hit during the Neoproterozoic, between 720 and 630 million years ago. Ice sheets spread from both poles, advancing until they met at the equator. The oceans froze to a depth of possibly a mile or more. Surface temperatures may have dropped to minus 40 degrees Fahrenheit at the equator. Imagine standing on what would one day become the Caribbean and being buried under a glacier. That was Earth. What ended the freeze? Volcanoes. They never stopped erupting beneath the ice, pumping carbon dioxide into the atmosphere for millions of years, with nowhere for it to go. No photosynthesis to absorb it, no weathering to lock it away. CO2 built and built until the greenhouse effect finally overwhelmed the ice, and the planet thawed in a geologically rapid and catastrophic warming event. And in the nutrient-rich, oxygen-rich, newly thawed oceans, something extraordinary was about to happen. The Ediacaran period. 635 million years ago, the ice had retreated, the oceans were warm and bathed in oxygen, and life, multicellular, complex, soft-bodied life, erupted into existence in a way that had never been seen before. These organisms, known as the Ediacaran biota, were like nothing alive on Earth today. They had no shells, no hard parts, no mouths in the conventional sense. They were flat and frond-like, or circular, or ribbed with mysterious symmetries that don't match any living animal we know. The most famous of them is Dickinsonia, a flat oval creature that could grow to over 4 feet across. It left impressions in the seafloor mud like a living pancake. Scientists debated for decades what it even was: a fungus, a protist, an early plant. In 2018, chemical analysis of a fossil from Russia, ancient fat molecules preserved for 558 million years, confirmed that Dickinsonia was an animal, the oldest confirmed animal ever found, and it looked like a fleshy ribbed mat. No head, no eyes, no limbs. This was the animal kingdom's beginning. Then, 538 million years ago, everything exploded. The Cambrian explosion. In geological terms, an eye blink, perhaps 20 million years, during which virtually every major body plan in the animal kingdom appeared simultaneously in the fossil record. Eyes evolved, shells evolved, legs and claws and fins and teeth, predator and prey locked into an evolutionary arms race that would never stop. The ocean suddenly filled with creatures of such alien strangeness that they look like the nightmares of a science fiction writer. Anomalocaris, a 2-foot-long shrimp-like predator with compound eyes the size of golf balls and circular mouthparts lined with serrated hooks, was the apex predator of the Cambrian seas. Opabinia had 5 eyes on stalks and a flexible clawed proboscis attached to the front of its head. Hallucigenia, named because the first scientist to reconstruct it had it completely upside down, walked on spike-like legs with tentacles erupting from its back. These were not primitive, simple creatures. They were sophisticated, complex, and deeply, profoundly strange. The seas were alive, and life was about to conquer the land. Fast forward to the Carboniferous period, 359 to 299 million years ago. The land had been colonized. Vast swamp forests covered the equatorial regions. Dense, steaming jungles of tree-sized ferns and club mosses stretching hundreds of feet high. These forests were so enormous, so productive, that they fundamentally changed the atmosphere. Photosynthesis ran wild. Oxygen content in the atmosphere climbed to 35%. Today, it sits at 21%. In the Carboniferous, every breath of air contained 2/3 more oxygen than today's, and that oxygen had consequences. Insects, which breathe through tubes that absorb oxygen passively from the air, could grow far larger in a high-oxygen environment. So they did. Dragonfly-like creatures called Meganera had wingspans of over 2 feet. 2 feet. A modern dragonfly fits in the palm of your hand. Millipedes, 6 feet long, patrolled the forest floor. Scorpions, 3 feet from claw to stinger. Giant cockroaches. Arthropods the size of small dogs. The forests of the Carboniferous were dominated by creatures that would look at home in a science fiction monster film. And they were real. The dead plant matter of those vast forests, so woody and novel that decomposing bacteria had not yet evolved the ability to break it down, accumulated in layers hundreds of feet thick. Compressed over millions of years, that plant matter became coal. The coal we burned to power the Industrial Revolution. I want to know what era of pre-human Earth haunts you the most. The magma ocean of the Hadean, the frozen silence of Snowball Earth, or the alien forests of the Carboniferous. Tell me down below. If this one changed how you see the ground beneath your feet, hit that like button and share it with someone who thinks they know this planet. And make sure you subscribe, because next week we're going into something that makes this look small. The evidence that Earth may not be the first rocky planet to ever host life in this solar system.